Kia ora, good evening. Welcome to Code Night New Zealand. And tonight we have a special guest, Nilesh Gul. How are you?
I'm doing good. How about
Yeah,
you?
doing well. Thank you. Oh, it's great to have you here with us tonight. You're bringing, well, it's been a while for the audience. Since like when I first touched base with Nilesh, it's been months and months. And now you finally are here, Nilesh. It's great to know that, well, you're near us here in New Zealand now, and
Yeah,
you're talking for Melbourne, right?
yes. I remember, I think it's almost like 6 months or 8 months before when we were
Something like
speaking,
that.
when I
Yeah,
was in Singapore, and then getting our times in the right time zone was difficult. Now
it
that
was
I'm closer
difficult.
to New Zealand, I think we can have a lot more sessions like this. It's really a pleasure talking to the community in New Zealand.
That's awesome. Thank you very much. And you're bringing a interesting topic tonight: event-driven autoscaling with using KEDA. Can you give like a teaser of what you're going to be presenting?
Oh, we will scale some pods in Kubernetes and we will see how you can trigger actions based on events. So I think if you look at modern day programming, people don't want to do like old style programming. They want to be more event driven. And we will see how we can use some of these tools at our disposal to make it happen.
Well, that's cool. Well, I'm very interested, like to check what you're sharing with us. But before Nilesh starts, I just would like to introduce the user group for you if you're coming like for the first time, right? As you can see here, like we are a community group of developers that we love coding and we follow best practices on software development languages and technologies. In general, mainly focus on Microsoft stack, but we are open to all technologies. And the intent of the user group is to enable developers with practical knowledge to excel and launch their careers. So if you're a junior dev, you're transitioning careers, you're a senior or lead developer, you're always going to find like great content in our sessions. I also like to mention that we're part of AzureTire.com, where we are a group of enthusiasts that get to talk about the latest and greatest on the cloud native space. In .NETFoundation.org, which is an entity that looks after the different open source .NET projects. And also sponsored by JetBrains, right? Software tooling for developers, like Nilesh and me and you as well. So with no further ado, Nilesh, the floor is yours. And if you'd like to bring your slides, I can
Yeah,
just
I will
share.
share my screen.
Yeah.
Let me know once you are able to see it.
All right. Here you go.
Okay, so let's get started. So, thanks everyone for joining. And as I said, it's really a great opportunity for me to connect with the people in this region. I was in Singapore for almost 14 years before moving to Melbourne. So, a bit about my background. My name is Nilesh Gule, or people call Nilesh Gul. Either way is fine. I put some links here for your reference in case you would like to connect with me over social media. I used to use Twitter long time back, but I've reduced my activity on the Twitter off late. But the other things they still work. I've switched more over to YouTube for content creation nowadays, and you might see a few videos coming up from my side published on YouTube on frequent basis. When I'm not talking or thinking about technology, I love the game of cricket, like many of the people from Indian origin, and I'm a big cricket fan. I spend a lot of time watching the game of cricket, not playing so much. In my younger days, I used to play, and I acquired some skills over the years. I've been in the industry for more than 20 years, and I perform various roles on the development as well as on the management side of things. So, before we start with today's topic, I would like to quickly give a brief overview of where I came from. I was born and brought up in this western coast of India called as Goa. It's a small state, one of the smallest in India. The reason I put this in the slides is because Goa is like a Portuguese colony, unlike the rest of India, which was a British colony. and you find a distinct change or difference in the culture in terms of the architecture of buildings, the style of people's cuisine, and the way they talk. So, if you happen to visit India anytime, I highly recommend to go and visit Goa. It's one of the most touristic places in India, and you find a lot of Bollywood movies being shot in Goa. I put some pictures of beautiful churches, temples, and tourist places here. And I hope if you visit, you will find it very interesting place. Now, coming to today's session, we'll be talking about Kubernetes-based event-driven autoscaling, and this thing is called as KEDA. It's an open source project, and there are many keywords here. We will try to decipher those keywords and see how does it actually work in the actual live environment. So we'll look at what are the different options for scaling in Kubernetes. Then we will have a quick overview of KEDA, and we will have a live demo as well. And we will close by looking at the architecture of KEDA. There are some prerequisites for this particular session. Because we are talking about Kubernetes, we are talking about containers. There are these set of tools, technologies that you need to have a bit of basic understanding. Starting with Docker or containers, how to package the applications using all its dependencies in a self-contained unit as a container. Then for orchestrating the container, we'll be using Kubernetes. And Kubernetes provides all these wonderful features like the self-healing, service discovery, scaling. And for the purpose of this demo, we will be using the Azure Kubernetes Service or AKS, which is a managed offering on Microsoft Azure, which also has native integration with other Azure services like the container registry, that is the container instances, Active Directory, and Azure Monitor, and so on and so forth. And we need to understand a bit about how container registry works. In the demo that I've built, this demo that I'll be showing has been built like over a period of 4 or 5 years. It has evolved from the time I started building that demo. I've used both Docker Hub as well as private container registry, so you could use any of the approach. In this particular case, I'll be showing the publicly available container images on Docker Hub, but I also have a version which works with private container registry using the Azure Container Registry. So, assuming that you have a bit of knowledge about this, we'll start by looking at what are the options when it comes to scaling the workloads on Kubernetes. First and foremost, there is the manual option where based on your experience or looking at the workload which is currently running, you want to manually scale maybe deployments or pods or services. The second option is the bit of like partial automation in terms of horizontal pod autoscaler, where you can configure based on the resource usage, like how much RAM is being used or how much CPU is being used. You can define a threshold, and automatically the number of replicas of your pods would be scaled, and it can also be up and scaled down. So that is the concept behind the horizontal pod autoscaler or HPA. Similarly, we also have the vertical pod autoscaler, where instead of creating multiple replicas, we scale the pod up, where we increase the resources which are allocated to the pod. And the last one is the cluster autoscaler, where we don't have enough resources on the existing cluster and we scale the cluster itself by adding more nodes to the cluster. So we look at some of these options, maybe starting with the manual one. Now, the demo that I'm going to show is a small demo application called as TechTalks. You can think of this like an application which is for managing the technical events, like a meetup kind of thing. And in this, we have a front end, which is a user interface built using the TechTalks React UI. There is the producer, which is producing certain number of events. It's a parameterized version, so we can say I want to produce like 500 events, 5,000, or whatever number we specify. Those many number of events will be produced. And we have a TechTalks consumer, which will consume those events. In this case, we are just picking up an image or event, sorry, tech talk, and then we log the details about that particular event. Now, this happens in a decoupled manner where we use a message broker in the form of RabbitMQ. And I'm also using a distributed application runtime called as Dapper, which allows us to work in a way to reduce the boilerplate code while working with the RabbitMQ. So the way this works is, first we will start without KEDA, like a normal application. We have the TechTalks producer and the TechTalks consumer, and the images are published for this application onto Docker Hub. We deploy this onto the Azure Kubernetes service, and we have this component called as Dapper, which does the interfacing between the producer and consumer to talk to the RabbitMQ. So let me start by showing some of this in the code so that you understand it better. Now, this is the first version of the code before I introduce Dapper. And let me know if the contents of this particular Visual Studio Code file is smaller. I can increase the font if required. So we'll look at the publisher code first. If you look at the publisher, it is looking at the key information or the RabbitMQ where we want to publish the message. That's the key or the routing key or queue name. In this case, it is named as hello because this was the first version of the code. But in the later versions, I've named it more like a RabbitMQ or TechTalks queue, something like that. And then we have this information regarding the host information. What is the connection string which is used to connect to that particular RabbitMQ? So we have the host name, the username and password, and then we retrieve this information from the environment variables. So we have this host name, username, password set as environment variables. And then there is a method for sending the messages. So this gets called. And as part of this, we also have all this boilerplate code for creating the connection factory, then creating a channel, then declaring the queue, and then actually setting some properties on that queue, like whether we want to persist the messages. And the last part is about serializing the message and sending it onto the queue. So if we look at all of this code, the actual business logic is very small, but there is a lot of boilerplate code in terms of just connecting to that RabbitMQ and sending the message. The reverse thing happens in the consumer side, where we have the same queue information and the routing key and the same three things, the host name, username, password. There is an additional thing about the batch size. This is the number of messages we want to pick in a batch when we want to process those messages. That's the only difference here between the producer and consumer. And initial part is again the same, where we create the connection, we create the channel, we retrieve the message based on that particular batch size. So we would fetch those many number of messages. And the last part is when the message is received, we decode that into a JSON object. And then finally, we log the details about that particular tech talk. So the logging is very simple. We write the tech talk ID, the name, category, and level. So these are the properties for that particular tech talk. So again, if you see the consumer side as well, the actual business logic is just retrieving this message and writing the details of that particular message. But just to pull that message from the RabbitMQ, there is a lot of boilerplate code which is written. Now switch over to the latest version of the code that I have. And I'm using this component called as the Dapper, which allows us to have a distributed application runtime. And one of the things Dapper has is it has these pops up mechanism or facility to define a publisher and subscriber. And via the configuration, we can process those messages. We can write messages to the queue and retrieve messages to the queue. Now, the same code, what I showed you earlier, if you look with the Dapper enabled thing, we just have to provide the publisher name, topic name that we want to use. And then there is the publish event onto that particular topic and the pubsub. That is all we need. So all that uh, other code which was doing the connection to the RabbitMQ and all that is abstracted away from us. On the consumer side, it is again the same. We have a message or a method called as process, which takes the information from the body of the message. And here we just say with the topic on the RabbitMQ PubSub component, there is a queue called as TechTalks. That is all the configuration we need on the consumer side. And all that, again, boilerplate code is no longer required here. So I suggest that if you are interested, have a look at the Dapper. So in the links that I've shared with Marcel, you have both the versions. The one which is the older version where we have all the boilerplate code, and the new one, updated version with the Dapper as well. Now, assuming that we have all this, we have created our producer and consumer, and we have the application installed or deployed on our Kubernetes cluster. Let's go and generate some workload and see how this works. So in my configuration, if I look at the current configuration under the Kubernetes files, manifest files for the TechTalks consumer, I have now this Dapper thing that I was showing. I have created a code base which is like portable. Initially, I showed you the code which was in .NET, the producer and consumer. I still have that .NET code under the source code folder here, but I've also added the Go and Java versions. And for this demo purpose, I'm using the Go version, but we can easily switch between any of these supported languages. So here, I will go back to the manifest file and let's see what are we using for the deployment. So in the deployment manifest for the consumer, we have one replica running, and we have the things for Dapper configured here. Like we want to use Dapper true means it will automatically connect to the Dapper instance. And then we have the container image which we want to use. So I'm using the public Docker image here named as TechTalks consumer and the Go version of that image. Same way, I have the producer, which has got 3 versions or 3 replicas running. So let's look at the producer. In the producer deployment, you can see 3 replicas here. So let's go on the terminal. I'm using a warp terminal here. And again, on my YouTube channel, I've done a few videos about how this terminal is very user-friendly, like developers friendly. So let's go and say kubectl get deploy and see what are the deployments we have. We have the producer deployment and we have the consumer deployment, and we have 3 replicas of the deployment for producer running. Now let's do one thing. Currently, there are 0 replicas of a consumer running. Let's scale this to 1. So this is the option I was telling you when we were looking at the different options in Kubernetes for scaling. So this is the manual option where if I want, I can say kubectl and scale the deployment. And the name of the deployment is the RabbitMQ consumer deployment. And the number of replicas I want is, let's say, let's start with just 1. And it has been scaled to 1. So now if I want to generate a workload, I can go into this browser and let's say I want to generate 500 messages or 500 tech talks. I have a RabbitMQ management UI here. So you will see in the properties of the queue, we had 500 messages published. And because we had that batch size of 50 messages have been picked. And in the consumer side, you can see 1 consumer running here. Now what will happen is this will process 50 messages in 1 batch, and it will keep processing them, keep writing it to the log saying, I consumed this. And to verify that, we can quickly go into Lens. Lens is again IDE or user interface for checking the state of the Kubernetes cluster. So in my consumer, I have this consumer deployment, And under the logs, we can find what is written. So we can see a real-time log here, and it says the TechTalk ID is 365. The name is Miss Julie Hack. Category is 2, level is 1, and this it will do for every message that it is picking. So we saw that 50 messages is the max size in one consumer that is being processed, and until all the messages are processed, it will continue picking the next batch of 50. Now let's switch back to our presentation. So we know that this thing works. The producer and consumer are working fine. The problem statement for today's session is, why do we need like event-based scaling, or why do we need event-based processing? There are scenarios where we might have unpredictable workloads. This could be like special events where if you are an e-commerce site or any business which wants to do, let's say, a special promotion on things like Christmas, New Year, Diwali or Deepavali or Thanksgiving or anything like that. Nowadays, I see that most of the e-commerce site, they also have these 1st of January, 2nd of February, 3rd of March, like 1, 2, 2, 3, 3, all these kind of days, they would promote some things. And you would expect a lot of traffic to come to your site, and you might have this burst load which is coming for a very short duration of time, and you don't know exactly how to predict the workload in such cases. The other reason could be you want to scale based on the factors which are outside of your Kubernetes cluster. If we look at the other options which I mentioned earlier, the horizontal pod scaler, HPA, as well as the vertical pod autoscaler, they both work on the information which is available within the Kubernetes cluster. Now, if we want to scale based on a factor which is outside of Kubernetes cluster, then it could be tricky, and it is very tricky to do it using the normal Kubernetes resources. We might also want to scale based on a combination of factors, not just one, like not just, let's say, CPU or RAM utilization. We might want to combine multiple triggers to scale. And then a negative scenario could be where you have an unexpected event. Like, let's say you are dependent on a third-party service, you are integrating with some other provider, and something goes wrong with that provider, and you're not able to communicate with that, and your service is creating huge number of logs. And in that case, you might want to take a different approach to scale your application. So these are some of the different scenarios in which we might want to have event-based scaling, or scaling based on some sort of external trigger. So that is where we are going to look at KEDA. KEDA is an open source project, which is the full form of KEDA is Kubernetes-based event-driven auto-scaling, and it has all those elements that I described earlier. So in this case, we are going to extend the earlier example that I showed, and I'm going to use KEDA as a resource within my Kubernetes cluster. KEDA is going to look at my RabbitMQ as the source, and it's going to see how many messages are there in the queue. And if there are enough messages to be processed, KEDA will automatically scale the consumers, because on our side, the unit of processing is the consumers here. So I want to scale the number of consumers based on how many messages are there in the queue. So let's look at this particular example. How does this work? So to enable this, I'm going to run a small script, or I'm just going to enable the KEDA autoscaler, which is part of a PowerShell script I've built. So in here, okay. So this deploys some resources on my Kubernetes cluster. It deploys a secret for connecting to the RabbitMQ. Then it creates an object of the type ScaledObject, and we will look at that definition of the ScaledObject. And it also creates what is called as a trigger authentication. So this is a way to connect KEDA to the source of the trigger, which is RabbitMQ in our case. So once these resources are deployed, now if I go, and look at the RabbitMQ, we see there are no messages to be processed at this moment in time, and the consumers are zero. We don't have any consumer running right now. So let me go and generate a workload here. Let's say I want 10,000 maybe messages or events to be produced. And let's look at the UI here as the events they get produced. So this UI refreshes every 5 seconds, and we see that the events have started coming. Currently, there are 295 or 500, and we see 50 messages have been picked, which means there is one consumer running. Now, what I'm expecting is in a short period of time, this number of consumers will increase because of that autoscaler which I've deployed. And I will also run a small thing here. Let's say kubectl get pods, and we can put a watch to see how the pods are getting created. So you see the RabbitMQ consumer pod. It's some of them are running here, some are in pending state, some are in creating. And if I go back, right now 8 consumers are running, then it becomes 16 because progressively it will keep on increasing the number of consumers since we already have messages. You can see the message count here at the top. We have around 1,800 messages in the queue, and 1,200 are being picked or processed because right now we have 30 consumers running here. Now this will stop at 30 because I put the limit in my configuration as 30. And all those 30 consumers, they will be processing in parallel. So with that, let's go and look at the configuration that enables us to do this. So I have this configuration for the scaled object. This is the link and a very critical component of whole of KEDA, which looks at what is the scale target. The target that we want to scale in this case is our consumer deployment. So this particular scaled object and KEDA is looking at the RabbitMQ consumer deployment as the target to be scaled. It's going to look every 60 seconds. The polling interval is how frequently it should go and check. And we specify the minimum replica count as 0 when there are no messages to be processed in the queue. And the maximum is 30. That is why you see that this stops at 30. It doesn't go beyond 30 consumers. And then we define what is our trigger for this particular scaling to happen. KEDA has different types of scalars, and the one we are using here is RabbitMQ. That is why the type is specified as RabbitMQ. And then we specify some metadata in terms of which is the queue that we want to connect to, what should be the queue length. For the purpose of this demo, I've specified the queue length as 5, but in an ideal scenario, you would have this length as slightly bigger number of messages. And then the protocol. We are using AMQP protocol here to connect to that. And it requires the authentication in order for the scaler, the autoscaler to connect to the RabbitMQ because it needs to look at how many pending messages are there. So we define that as a custom object again in the KEDA. So this trigger authentication is a type of object created specifically for KEDA, and it takes this parameter as host and it takes a secret. So the secret which is created is basically the username, password, and whatever connection string we would put in a normal RabbitMQ connection. So we put, this is usually the syntax, AMQP, whatever is the user, the password, and then the cluster for RabbitMQ, the port, and then the queue name. So this is put as a RabbitMQ secret, and that gets used in our scaler here. So using that information, it periodically checks using this polling interval how many messages are pending, and if there are enough messages still to be processed, the scaling would happen between the minimum and maximum replica count. And now if I go back, we will see that all the messages have been consumed here. We still have these consumers as 30, because there is a cooldown period. It will look at a cooldown period, which is, I think, 5 minutes, if I'm not mistaken. The default time is 5 minutes. So if there are no more messages to be processed for next 5 minutes, then the scale down will be triggered, and this 30 consumers will be scaled down all the way back to zero, or whatever is the minimum. In this case, my minimum replica count is zero, so it will scale it down to zero. So how does KEDA do this? Uh, KEDA resides within the Kubernetes cluster. We add KEDA. I've used Helm chart, which is a mechanism for installing KEDA onto the Kubernetes cluster. When we install KEDA, it adds things about this scaled object that I showed, the definition. It also looks at the external trigger source. And based on that, it uses the horizontal pod autoscaler to create multiple replicas of that particular deployment. So if I go back again on the terminal and we see what are the objects which are created by KEDA, there are some custom resource definitions or CRDs. When we query the CRDs, you can see there is this cluster trigger authentication. So all the resources or the custom resources, CRDs ending with .keda.sh are the ones which are created by KEDA. So we have this first one, which is the cluster trigger authentications. Then we have scaled jobs. Then there is scaled objects. And then there is the trigger authentication. So these are the four objects which custom resources KEDA creates. And in the pods or in the objects which are created, it also has these admission webhooks, and the operator as well is created, and a metric server. So using all these information or the custom objects, it is able to pull information from our trigger source, and it is able to look at our deployment, which is already running in the Kubernetes cluster, and it is able to scale within the range that we specify. So this is the information that we looked at in terms of the scale object. The type of object or the custom object is scaled object. And the important things there is the target that we have to specify, which was our consumer, and the type of trigger. So our source is RabbitMQ, and that's why we specify the trigger as RabbitMQ, and the additional metadata so that it can take this metadata into effect when we do the auto scaling. Now, these are some of the features of KEDA. We already looked at the auto scaling, how easy it is to scale with the KEDA. It's also event driven, which we saw that only when there were events to be processed, it was able to scale from 0 all the way to 30. There are built-in scalers provided by KEDA. The screenshot here on the KEDA website says 50, but as of today morning, there are actually 70 scalers. So if we go at the scalers documentation, you see there are 70 scalers are available, and these range from different types. You have the built-in scalers, you have the external ones. These are also into different categories like messaging ones. So ActiveMQ is there, Kafka is there. You have Pulsar, AWS Kinesis, Azure Event Streams, all these messaging-based scalers. Then you also have data and storage, like the blob storage. There is DynamoDB. You have different data stores, like the ArangoDB. Then the Matrix, like the CloudWatch, Azure Monitor, Datadog, Dynatrace, and all these different types of uh, operations or different types of sources can be used as a trigger source for KEDA. So when I started, KEDA had like out of box 7 or 8 scalars, and over the last 3 or 4 years, it has reached 70 out of the box autoscalers right now. So the project is quite popular, and the number of autoscalers is also increasing day by day. The other features include multiple types of workloads. So we looked at deployment as one of the type of workload for automatically scaling, but you can also scale jobs. If you have a Kubernetes job, that can also be scaled based on all of these metrics. And even the custom resources which have the scale option, that can be scale as a sub resource that can be scaled using KEDA. And because we have this option of scaling all the way to zero, there is also this reduced environment impact. You see all of these things coming into picture with regards to sustainability, where people are trying to reduce the carbon footprint. So it helps the environment in one way. And we can also extend KEDA. One of my friend actually built a KEDA autoscaler for, I think it was ActiveMQ, if I'm not mistaken. That scaler is coming from community, and it was built by one of my ex-colleague. So using this concept of autoscaling, if there is no existing autoscaler, we can build our own and contribute back. And this is vendor agnostic. All we need is a Kubernetes instance with version 1.17 as the minimum one. As long as your Kubernetes version is 1.17 and above, you can install KEDA on your cluster and it will work in your Kubernetes environment. And Azure Function support also exists for the serverless kind of scenarios. So we looked at some of these scalars, and I put that again in terms of what kind of scalars are supported. So the triggers which are supported include not just the Azure, but also open source projects, databases, messaging, custom products. Everything can be used as long as it has the ability to look at those metadata. And we also have the benefit of scaling it back to zero. In many of the other scenarios where we are using horizontal pod autoscaler and all, we can't scale back to zero. We need to have minimum one replica running. But in this case, KEDA supports scaling down all the way to zero, which can help you save on the cloud cost if you're running this on cloud. So in summary, we can say that KEDA is very helpful in terms of auto-scaling the application based on metrics which are external to the Kubernetes cluster. The important thing to note here is KEDA does not modify anything in terms of the behavior of the application. Now, whatever I showed you, I can just remove KEDA from my Kubernetes cluster, and my application, which is the TechTalks application with producer and consumer, will still continue to work. The application doesn't even know that it is being scaled. KEDA works externally to the application, and the application doesn't need to even know that there is KEDA installed on the cluster. So if you don't want to use KEDA at a later point in time, you can just remove KEDA from your cluster and your application will still continue to work as expected. The other thing which I find very interesting here, or to note here, is the application should be designed using cloud native approach. And these kind of applications are the ones which are more suited for KEDA integration. What I mean by this is, in this example, if you saw, my batch size was 50 for picking up the number of messages. Now, if I don't have option of like slicing the trigger point, then KEDA will not be able to scale. If the application can't process in smaller chunks, then KEDA is or scaling the replicas will not help in that case. So the application has to be able to process information in smaller chunks, which is usually what cloud native applications are doing, or they are supposed to do. So they have to be designed in a cloud native way. KEDA also helps in composite metrics. And what I mean by this is we can combine multiple metrics and we can define formulas, and it can trigger based on not just one metric. In our example, we just looked at the number of messages in RabbitMQ. But if I want, let's say, number of messages in RabbitMQ, and also I have Prometheus, for example, as a source, and the average number of metrics in Prometheus is something, I can combine those two, and then I can decide how I want to scale my workload. And in my example, I showed the credentials. They were stored as a Kubernetes secret, which is just a base 64 encoded data, which is not a very secure mechanism to store like sensitive information. And for that, KEDA supports authentication providers. We can have things like Azure Key Vault and HashiCorp Vault. These kind of supported vaults can be used to store the sensitive information and pull that information at runtime without exposing it as part of the Kubernetes cluster. So with that, we have come to the end of this demo and the session. Here are some of the references in case you want to learn more about KEDA and whatever other things I showed here. I've put the links to the KEDA itself. The KEDA.sh is the homepage for KEDA. I also talked about Dapper, the distributed application runtime, which enables us to build the uh, portable applications. So I put a link for that. And uh, there was a mention about Azure TAR. Marcel talked about it. So I had the opportunity to do a session with George, who is hosting many of these sessions for Azure TAR. I talked about how to use Dapper uh, in Azure Container Apps. So again, because I was using Dapper, it was easier for me to move from like a fully managed Azure Kubernetes cluster to a Azure Container Apps kind of a environment based, like a serverless service. So I have this talk in case you are interested to know. It's the same application that I demonstrated here, but running in the Azure Container Apps environment. And then I also did a series on my YouTube channel, which is called the Cloud Native Ninja, where I talk about taking this application and then starting from right beginning, how you containerize the application, how you use CI/CD to deploy that to Kubernetes, and various other aspects related to building cloud native applications. I hope you might find some of these contents useful. So these references or the links to the GitHub repositories for both the applications, the original version with only .NET code and the Cloud Native Ninja, I've already passed it to Marcel. He might have put it in the sessions detail. These slides that I used, they are available on SlideShare and Speaker Deck. You can search with my name, my first and last name, Nilesh Kule, and you will easily find them. Thanks for attending the session. Again, in case you came in a bit late, my name is Nilesh, and these are the public profiles that I have or social media links I have. My name is quite unique, the combination of my first and last name. So I usually find everywhere I don't have to append or prepend anything. I usually find the profile with just my first and last name combined together. So hopefully you found this useful. In case there are any questions, I'm happy to take them.
Yeah, English. So yeah, awesome session. Thanks for
Thank you.
sharing with us. We got like some questions around like KEDA. The first
Okay.
one is from Sinam. So he asked, can we use KEDA with container apps?
Yes, of course. So that is what I just mentioned a few minutes back. So I have this demo which is running on the Azure Container Apps as well. So if you go on the Azure tar, and it's also there on my YouTube channel under the public talks. So let me quickly show you. You should be able to find it on my YouTube. Oops, what happened? If you go to the public and the conference talks under this list, you will find that Azure Tar talk here, the microservices development with Azure Container Apps. And in fact, Azure Container Apps has a native integration with KEDA. So we don't even have to enable anything for running KEDA on Azure Container Apps. On the Kubernetes, there is this flag which we have to enable. It's like a add-on or an extension for Kubernetes, AKS. But Azure Container Apps has by default integration with KEDA, and you can use KEDA straight away.
Cool. We have like another question. So does like KEDA work with Azure Storage Queue? So Prakash is asking that.
I need to check on the scalars, and if I go on, let's say storage, mm, Azure storage queues, yes,
It's in
you
there.
can. Yes, it's there. So you can just go to this keda.sh, and under the docs, look at the scalars. It's one of the top level resource. So if you look here under the docs, under the scalars, you will find all the built-in 70 scalars which are supported by KEDA. You also find the examples like, let's say I want to look at what is the configuration, the metadata which is required for Azure Storage Queue. So based on the source of the trigger, you will see that the metadata varies by every trigger or every scalar.
Cool. Yeah. So a lot of options. So as it's open source, right? So you mentioned
Yes.
like that one of your colleagues working on the creation of one of those
Yeah.
connectors, right? Scalars. So well, if you don't find what you need, so you can start like your own version, make it
Yeah.
public. So that's cool.
Yeah. This is the one I was telling. ActiveMQ. You see, this is the maintainer community.
Yeah.
So this scalar is built by my ex-colleague.
All right. So that's cool. If I have a question, like for the source code that you provided, so did you provide like even the Helm chart for
Yes.
the everything? Okay. Yeah.
Yeah. So if you go into my Visual Studio repository, right, or GitHub repository,
Hmm.
you will find all the resources here. I initially started with PowerShell, and then I've also now started to put things like Terraform. There is also Helm chart, and on my YouTube channel, I did that. So if you go back to my channel, you will find that the Cloud Native Ninja series that has these steps covered. So let's say in the playlist, you can head over to Cloud Native Ninja. So far, there are 16 videos of this, and I show you uh, how to do like what's the concept behind this, getting started with containers. Then I covered Dapper, then containerizing .NET and Docker Compose, then how do we publish the images, and somewhere along this line, you will also find how to package the application using Helm chart. So this is for packaging the TechTalks application. And if you want to look at the KEDA Helm charts and all, you will find them under these scripts. So they are under PowerShell, and you will have things like deploy KEDA, and you will find the Helm commands for that.
Cool. Cool. Yeah. I don't think we have like any other questions. Oh, that was like a pretty good like session. I learned lots with
Thank
that,
you.
and I hope like the audience also like had the opportunity to learn more with you. And for sure, like I'm gonna be checking like your Ninja YouTube sessions to learn more.
Yeah.
Probably others on the
And
audience
I'm
as
open
well.
for contribution. I don't have time to do everything, So if somebody wants to contribute to that repository, you can raise a pull request, and I'll be very happy to merge that.
Sounds good. Well, thanks so much, Lesh, for coming and sharing with us. Yeah, it's a
Yeah.
pleasure. If you have like
Thank
more
you.
sessions in future, well, you're welcome to come back.
Yeah, I would love to.
Nice.
Thank you for the opportunity. It was really a wonderful experience for me.
Nice. Well, you're very welcome, mate. Yeah. And well, do you have like any final considerations?
Oh yeah, someday I would like to visit New Zealand and maybe do this, not this kind of session in person.
Yeah. Well, when you come here, ping me. We can arrange something. Yeah.
Sure.
All good. Thanks, Lesh. And thanks to the audience for tonight's session. We always have sessions arranged in between 3 to 4 weeks. Just keep an eye on the Meetup user group. Be in touch. Like if you have any further questions, I have shared your links, Lesh, during the session, but I'll
Okay.
also copy them and put like under the Meetup uh, comment section. So everyone's going to have access to those links. Well,
Okay.
thank thank you very much again, Nilesh. Thanks to the audience. And with that, see you guys next time.
Bye.
Cool. Cheers. Thank you.